Hi everyone. In this video, we are going to discuss about the Pythagorean identities of the trigonometric ratios. In our previous video where we discussed about the trigonometric ratios, there we have understood that the 6 ratios which are sin theta, cos theta, tan theta and cosec theta, sec theta and cot theta, what their values are, that we have understood. Now I have the right triangle in this picture here and I have the 6 trigonometric ratios on the left hand side here. So now since it is a right triangle, we all know that there is a theorem which is called Pythagoras theorem, and the theorem says that the sum of the squares of two sides is equal to the square of the hypotenuse. So now here I am going to say, okay, so if non-hypotenuse sides which are nothing but a and b, so the sum of their squares, that means a squared plus b squared, that is the sum of their square, would be equal to the square of the hypotenuse. So this is what Pythagoras said, that for any right triangle this is always true. So using the Pythagoras theorem, we can now come up with some relationship between the different trigonometric ratios. So now let's get started. So from here we can say, okay, if we divide both sides of this equation by c squared, so now we are dividing both sides by c squared, so we'll get a squared divided by c squared plus b squared divided by c squared is equal to c squared divided by c squared, which will become 1. So let me scroll down, and then from here we can say, okay, so it can be written as a by c whole squared, a squared by c squared can be written as a by c whole squared. Similarly, b squared by c squared can be written as b by c whole squared is equal to c squared by c squared, that will become 1 because the c squared in the numerator and the denominator, they will cancel each other, so that becomes 1. And from here, if you see right here, up here, a by c is nothing but cos theta. So where we have a by c, I am going to write it as cos theta, and then similarly b by c is nothing but sin theta. You see the a by c right here, a by c and then b by c. So a by c is cos theta, b by c is sin theta. So can we write it like this? A by c, that is cos theta, so you can say cos theta whole squared plus sin theta whole squared is equal to 1. And then the way we write the exponent for these trigonometric ratios, it's kind of like this. We really don't say cos theta whole squared, it is generally written as cos squared theta. So it would be cos squared theta, that is actually cos theta whole square. So any exponent, the exponent is written like this, it's before the theta but after the actual name of the ratio, so it is like cos squared theta. And then similarly we can say sin squared theta right here, so this is sin squared theta is equal to 1. And if we then write it like this, sin squared theta, so sin squared theta plus cos squared theta is equal to 1. This is our first Pythagorean identity of the trigonometric ratio. So let me highlight this. Now let's talk about the second Pythagorean identity. Again, we are going to begin at the same equation, a squared plus b squared equals c squared. Now we are going to divide both sides by a squared. So let's divide both sides by a squared and see what happens. So if we divide both sides of this equation by a squared, so it will be a squared divided by a squared plus b squared divided by a squared is equal to c squared divided by a squared. And from here we can say, okay, a squared divided by a squared, they're going to cancel out each other, so this becomes 1 plus this becomes b by a whole squared is equal to c by a whole squared. And from here we can say, okay, hence we get 1 plus, now what is b by a? So b by a is actually tan theta right here, b by a is tan theta, and then c by a is sec theta. So c by a is sec theta and b by a is tan theta. So let's put that value. So this will be tan square theta is equal to secant square theta. So this will be secant square theta. So from here we can say, so secant square theta is equal to 1 plus tan square theta. So this is the second Pythagorean identity of the trigonometric ratio. So let me highlight this also. Now let's talk about the third Pythagorean identity, and again we are going to begin with the same Pythagoras theorem right here, a squared plus b squared. So we are going to start with the a squared plus b squared is equal to c squared, and this time we are going to divide both sides of this equation by b squared. So now let's divide both sides by b squared and see what happens. So it would be a squared divided by b squared plus b squared divided by b squared will be equal to c squared divided by b squared. So we are pretty much dividing each of the terms by b squared. So from here you can see the first term becomes a by b whole squared, that is a by b whole squared, and then the second term becomes 1 because the b squared squared and the b squared, they're going to cancel each other. So that becomes 1, and then on the right hand side it is c by b whole squared. Now what is a by b and c by b? Let's go up there and see what we have there. So c by b and a by b. Okay, so c by b would be cosec theta, and then a by b is actually cot theta. So cosec theta and cot theta, right? So c by b is cosec theta. So this will be cot theta. A by b is actually cot theta. So this should be cot square theta plus 1 is equal to, this one will be cosecant square theta. If we write it like this, that cosecant square theta would be equal to 1 plus cot square theta. So let me highlight this also. So those are the three Pythagorean identities of trigonometric ratios that we have, and from each of them we can also do a little more analysis to come up with a few more relations here. So let's try that and see what happens. So now I'm going to write it on the side here. So let's say, suppose we know that sine square theta plus cos square theta is equal to 1. So from there we can say, okay, if that is the case, then can we write it like this? Can we say that sine square theta plus cos square theta is equal to 1? From here, can we say, okay, so sine square theta would be equal to 1 minus cos square theta. 1 minus cos square theta can be written as 1 squared minus cos square theta, or minus cos theta whole squared, and this is like an a square minus b square form. So this will become a plus b times a minus b. So this can be written as 1 plus cos theta times 1 minus cos theta. So from here we can say, okay, so our sine square theta is actually, so this is our sine square theta, and then if we keep one sine theta on the left hand side, so if we keep one sine theta on the left hand side and then bring one of the factors from the right hand side to the left hand side, so it would be sine theta divided by, let's first bring the first one, right? Say 1 plus cos theta would be equal to 1 minus cos theta. The other factor will remain on the right hand side, and then one of the sine theta would go to the right hand side, so it will go into the denominator. So we can say divided by sine theta right here. So that is also another relationship that we can come up with. And similarly, I can write down another relationship that we can say, okay, it will be cos theta divided by 1 plus sine theta, and this will be equal to 1 minus sine theta divided by cos theta. You can try it yourself and it will come up like this. So now let's look at the second one also. From the second one we can do something here. So here this is pretty nice here. So we can say, okay, we have secant square theta is equal to 1 plus tan square theta. Can we write it as secant square theta minus tan square theta is equal to 1? So from here we are writing like this, and then from here we can factorize it. We can say, okay, this is a squared minus b squared form, so it would be a plus b times a minus b. So I can say this times a minus b, which is sec theta minus tan theta, is equal to 1. So each of these factors, they are nothing but the reciprocal of each other because their product is equal to 1. So we can say, okay, one of the factors will be equal to 1 divided by the other factor. So if we say, okay, we can say sec theta plus tan theta will be equal to 1 divided by sec theta minus tan theta. You can also say that sec theta minus tan theta will be equal to 1 divided by sec theta plus tan theta, right? And then from the last one, there also we can do something similar. So from this one we can say, okay, can we write it like this? Can we say cosecant square theta? So from here we're going to say cosecant square theta minus cot square theta is equal to 1, and then we can factorize again. So it would be cosec theta plus cot theta times cosec theta minus cot theta is equal to 1, and from here we can say, okay, now it's very clear that each of the factors is a reciprocal of the other one because the product of the two factors is equal to 1, so each of them will be reciprocal of the other one. So we can say, okay, then cosec theta plus cot theta is equal to 1 divided by cosec theta minus cot theta. Or similarly, we can also say like this, that if we keep the second factor on the left hand side, so from here also we can say that cosec theta minus cot theta will be equal to 1 divided by cosec plus cot. Right? So those are the three Pythagorean identities of the trigonometric ratios. I hope everything made sense so far. Thank you for watching. See you in the next video.